Hello guys, today we start with the topic sums of chapter 1 arithmetic sequence. See in this figure, these are rows. How many rows are there? 10 rows. How many dots are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 dots of each row, and like that 10 rows are there. So how many dots are in total? How many dots are in total? 11 dots of 10 rows. So total number of dots is 110. If you make it half, 1, 2, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 10. See, like this if you join. See, now we get a triangle. How many dots are here? If not joined properly, then also consider it is joined. So how many dots are here in this half triangle? Half of 110. That will be half into 110 equals 55. You see in the first row 1 dot. Second row 2 dots. Third row 3, 4, 5, 6, 7, 8, 9, 10. Like that also you can count. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9 plus 10 equals how much? Equals 55. So we can do this in another way. Let me rub this figure. Sum of 10 terms. Let sum is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 in the half triangle. Now one more triangle is there. S is equal to, I will write 10 plus 9 plus this way. 8, 6, 5, 4, 3, 2, 1. Adding S plus S. 2S is equal to 11 plus 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 11. How many 11s are there? You see how many 11s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 11s. So 1 11, one sum, that is S is equal to half, no, 11s, 10 11s are there. That divided by 2. So 2S is equal to 10 times 11. That is, therefore S is equal to 10 into 11 by 2. We will get 55 as the answer. See, if we count up to 100, you have to find the sum up to 100. What you will do? See, this method you can follow. Let S be the sum. 1 plus 2 plus 3 plus, if you want to find out the sum of 100 terms, 98, 99, 100. Now write in, this is ascending order, now we are going to write in descending order. Bigger one first. 100, 99, 98 plus dash dash plus 3, 2, 1. Adding s plus s, 2s is equal to 101 plus 101 plus 101 plus dash dash. Here also 101 plus 101 plus 101. How many 101s are there? See, 100 times 101 is there. 100 times 101 is there. So we can write 2s is equal to how much? 100 times. 100 times 100. So 2s is equal to 100 times 101. Therefore s is equal to 100 into 101 by 2. We can cancel 50. 50 into 101 is, answer is 5050. So sum of first 100 natural numbers is 5050. See here, 100 is the total number of terms. 100 is the total number of terms. 101 is next to 100. Next number to 100. Half of that. So, sum of any number of consecutive natural numbers starting with 1. Starting with 1 is half the product of last number. Half the product of last number and the natural number next to it. What is that? Once more I will say, the sum of any number of consecutive natural numbers, 100 terms are there, 100 numbers are there, starting from 1. Starting with 1 is half the product of, this is product now, half the product of last number. What's the last number? 100. And the number next to it, next of 100 is 101. So s is equal to 100 into 101 by 2. You will get 5050. Instead of 100, let me write n. Suppose it is n. Sum of n terms. If you want to find out the sum of n terms, consider 1 plus 2 plus 3 plus dash dash up to n. What we have studied? Half the product of last number into number next to it. See, half n into n plus 1, or you can write n into n plus 1 by 2. So, sum of n natural numbers is of the form n into n plus 1 by 2. This is the algebraic form. The language of algebra, sum of first n natural numbers is n into n plus 1 by 2. Consider another sequence. You see 2, 4, 6, dash dash. Up to 100 if you want to find out the sum of 100 terms. Dash dash up to 100. How to find? 2 plus 4 plus 6 plus dash dash up to 100. We can take 2 as common factor from this. 2 into, they are even numbers. Taking common factor means dividing each term by 2. 1 plus 2 plus 3 plus dash dash up to 50. 100 by 2 is 50. So here we can apply that algebraic form. 2 into half into last number into number next to that, 50 into 51. So 50 into 51, what is 50 into 51? 2550. This is the sum of even numbers up to 100. In general, first even natural numbers are, we have studied earlier, first n natural numbers are of the form 2, 4, 6, dash dash. They are of the form last xn is equal to 2n. We have studied for even numbers last term, that is xn is equal to 2n. How to find their sum? In order to find their sum, 2 plus 4 plus 6 plus dash dash up to 2 is equal to, we'll write sum s is equal to, can take two common factor, 1 plus 2 plus 3 plus dash dash plus n equals 2 into. Now we have studied sum of first n natural numbers is n into n plus 1 by 2. n into n plus 1 by 2. Cancel this. N into n plus 1. So, sum of first 2n even natural numbers is n into n plus 1. Now we have studied the algebraic form of or xn of odd numbers. Even numbers this. Now consider the odd numbers. 1, 3, 5, dash dash. Their xn is 2n minus 1. We have studied in the previous class. Xn is equal to, that is nth term, last term is 2n minus 1. Here first term is equal to 1. Second term is equal to how much? Or you can substitute in this xn. Xn is equal to, we are substituting value in this, xn is equal to, if xn is equal to 2n minus 1, x1 is equal, this will be very easy, 2 into 1 minus 1. x2 is equal to 2 into 2 minus 1. x3 is equal to 2 instead of n giving 3. Like that. xn is equal to 2n minus 1. I am writing once more. 2 into n minus 1. Adding all these. This is xn. x1 plus x2 plus x3 plus dash dash up to xn is equal to 2 into 1 minus 1. 2 into 1 minus 1 plus 2 into 2 minus 1 plus dash dash up to 2 into n minus 1. See, you can simplify further. See here, 2 everywhere. If you write one more term here, it will be 2 into 3 minus 1. So, x1 plus x2 plus x3 plus up to xn is equal to, see here 2 into 1, 2 into 2, here everywhere 2, 2, 2. So, we can write it as 2, how many 2's are there? See, up to n terms. So, 2 into 1, we can take this as common factor. We can take 2 into 1, we can take it out. 2 into 1, 2 into 2, plus dash dash 2 into n. Here, minus 1, minus 1, minus 1, minus 1. How much? Minus 1 plus dash dash plus 1. How much? N times. That one is in n times. So we can write, we can take two common factor from this. We'll get 2 into 1 plus 2 plus 3 plus not written 3 dash dash up to n minus 1 how many times? N times. So what we will get equals 2 into, so 1 plus 2 plus 3 plus up to n is n into n plus 1 by 2, that you can write here, n into n plus 1 by 2 minus 1 into n is minus n, get cancelled, open the bracket, n into n square plus n into 1 n minus n is equal to n square. Sum of first n natural numbers is of the form odd numbers, not natural numbers, odd numbers is of the form n square. See that n square is the sum of first odd natural numbers. I will give one example. Here 1 plus 3 plus 5, these are natural numbers, their sum 9. 9 is equal to 3 square. Here we have 3 terms, so 3 square. If we have n terms, n square. Now again 1 plus 3 plus 5 plus 7 is equal to 8, 7, 16 is equal to 4 square. We have 4. So 4 square. If we have n, consider one more number, equals 25 equals 5 square. We have 5 numbers, so 5 square. If we have n numbers, n square. If we have 3 numbers, 3 square. 4 numbers, 4 square. So sum of first n odd natural numbers is n square. That is a general form, n square. So now we consider another example. Any algebraic term is of the form, any algebraic sequence is of the form xn is equal to an plus b, that we have studied. Any sequence is of the form is an arithmetic sequence, and any sequence of this form is arithmetic sequence. Any sequence of this form is arithmetic sequence. Here substituting n is equal to 1, 2, 3. Don't forget this. Xn is equal to, or another formula we have, another fact we have, xn is equal to dn plus f minus d also. Substituting x is equal, n is equal to 1. x1 is equal to a into 1 plus b. This is algebraic sequence expression, general form of any, write general form of or any arithmetic sequence. Now n is equal to 2, x2 is equal to a into 2 plus b. When n is equal to 3, x3 is equal to a into 3 plus b. Goes on like that. Xn is equal to, when n is equal to n, that is last term, xn is equal to an plus b, or you can write a into n plus b, that is the last term, nth term. Now we have to find the sum. We have to add all these. x1 plus x2 plus dash dash x3 plus dash dash up to xn is equal to a into 1 plus b, that is a plus b plus 2a plus b plus 3a plus b dash dash plus an plus b. See, this can be simplified further. Equals, see here, take all a outside and bring it to one bracket. A plus 2a plus a plus 2a plus 3a plus dash dash plus an plus, now b together, b plus dash dash plus b. How many b's are there? N times b is there. So here take a common factor, 1 plus 2 plus 3 plus dash dash up to n plus n times b, n into b. This is equal to a into 1 plus 2 plus 3 up to n. We have studied just now. It is n into n plus 1 by 2 plus n into p. See, x1 plus x2 plus x3 dash dash up to xn. Sum is a into n plus 1 by 2 plus n into b, or you can say bn, nb, n into b, or bn. For arithmetic sequence, xn is equal to, here xn is equal to an plus b. The sum of first n terms x1, x2, x1 plus x2 plus x3 dash dash up to xn is an into n plus 1 by 2 plus bn. An xn is equal to an plus b. Their sum of n terms is equal to a into a n into n plus 1 by 2 plus b n. This is sum of n term. Now consider another sequence, 1 4 7 dash dash. What is this xn? Xn is equal to dn plus f minus d. This way also you can find out, or with a common difference you can say that it is 3n minus 2. Difference 3n plus f, first term 1 minus 3, that is minus 2. This way you can get xn. Xn is 3n minus 2. Now how to find Sn here in this sequence? This is an arithmetic sequence. Now substituting, n is equal to 1. x1 is equal to 3 into 1 minus 2. n is equal to 2. x2 is equal to 3 into 2 minus 2 dash dash. xn is equal to 3 into n minus 2. So adding all these, what is the answer? x1 plus x2 plus dash dash up to xn is equal to, the previous example we did, 3 into 1 minus 2 plus 3 into 2 minus 2 dash dash plus 3 into n minus 2. So see, we can take common factor. We can take common factor from this. What is your common factor? Not common factor, we can take all threes outside. Equals 3 into 1 plus 3 into 2 plus dash dash 3 into n. Now we have minus 2, minus 2, minus 2 everywhere. Take minus 2 out. Minus 2 plus 2 plus dash dash. Here also minus 2. Minus is taken as common factor. So inside the bracket 2 plus dash dash plus 2. How many times? N times are there. So we can take 3 out as common factor. 1 plus 2 plus, next will be 3 dash dash plus n minus 2 n times equals 3 into this. We know what is that sum of first n natural numbers is n into n plus 1 by 2. N into n plus 1 by 2 minus this 2n. See, we can simplify further. 3n into n plus 1 minus 2 into 2, 4n whole by 2. This is equal to, opening the bracket, 3n square plus 3n minus 4n whole divided by 2. 3n square plus 3n minus 4n is minus n. Is equal to 3n square minus n by 2. So this is the sum of, or we can write half into 3n square minus n. This is the sum of n terms of this sequence 1, 4, 7 dash dash. Okay, now we move on to another question. Or you can simplify this further. Xn, general form, xn is equal to an plus b. Sn is equal to a into n plus 1 by 2 plus bn. Now, if you simplify further, you will get half taken out into a n plus 1 plus, here it will be 2 b n equals. You can take here also n, here also n. So half n into a into n is taken out, a into n plus 1 plus 2b equals half n into, opening the bracket, an plus a plus this 2b can be written as b plus b is equal to half n into 1b brings here an plus b, this b here and this a there, plus a plus b. This is equal to half n into n plus b is xn. A plus b is, substitute n is equal to 1, first term. So we come to another fact, another formula, that is Sn is equal to half n into xn plus x1, that is the sum of any number of consecutive terms of an arithmetic sequence is half the product of number of terms and the sum of first term and last term. Once more I will say, the sum of any number of consecutive terms of an sum, that is Sn. Sum of any number of consecutive terms of an arithmetic sequence is half the product of number of terms and sum of first term and last term. That is Sn is equal to half n into xn plus x1. Now we'll check in order to find the 100 terms of an previous example. In order to find 100 terms, the example we have taken is 147 dash dash. We have to find 100 terms. Find not last term, dash dash, 100 terms. We have to find 100 terms. So first we have to find 100th term is what? Equals n into, what is n? Here n is 100. So here 100 into, first you have to find out the 100th term. 100th term is, how to find the first term is 1, second term is 4, third term is 7. 100th term is, how to find the f plus n minus 1 into d. This is not 100th term, this is xn, general formula, general form. 100th term, x 100 equal first term 1 plus 100 minus 9, 99 into d is, common difference is 3, equals 97 to 98. 100th term is 290. So 1 plus 4 plus 7 plus dash dash up to 298 have to find the sum. The sum of first n terms of any arithmetic sequence has a definite algebraic form that we have studied earlier, an into n plus 1 by 2 plus bn. So 100th term is 290. If a sequence is given, you can find the any number of terms. Now the sum general form we have studied just now. Xn is equal to, not xn, Sn is equal to a into n plus 1 by 2 plus b n, or nb, you can say. See here, thoroughly we got the answer as half, taking half, open the bracket, an square plus a plus here 2 b n, half into an square plus an plus 2 bn, that is, opening the bracket, half an square plus, see, half a plus, here what is that? Get cancelled, half and this 2 get cancelled, this 2, so b, no need of, okay. So half a, what is, oh here one is there, an, half an plus b n equals half an square plus half, here we can take n into a plus b, is equal to half an square plus half a plus b into n. See here, half a plus b, half a r. If you take it as a constant, we can give the value p and q. So Sn will be, this you take it as p, n square plus, this take it as q, n. So sum of any number of terms, sum of n natural numbers, or sum of any terms of the sequence is of the form Pn square plus Qn, where P and Q are constants. Instead of half A given P, half of A plus B given Q. Now consider one example. Here consider the example that have to clarify each and everything. 2, 5, 8 dash dash. This is an arithmetic sequence with xn is equal to 3n minus 1. You check 3 into 1, 3, 3 minus 1 is 2. 3 into 2, 6, 6 minus 1 is 5. So how to find the xn here? This is xn. xn is equal to 3n minus 1. Sn is equal to 3 into, instead of n into n plus 1 by 2 minus, what we can write, minus 1, that is n dash. Our general form is a n into n plus 1 by 2 plus b into n. Here b is 1, that is minus 1. See here, minus 1 into n. See here, 3n into n plus 1 by 2 minus 1 into n. Take half common factor. You will get 3 opening the bracket and multiply 3n square plus 3n minus 2 into n, 2n is equal to half into 3n square plus 3n minus 2n is n. See, this is the Sn of this term. For each and every arithmetic sequence of natural numbers, we have the sum of n terms. We have the general form or algebraic form. Sn is equal to half into 3n square plus n. If any sequence is given, we can find the xn and Sn also. If Sn is given, can you find the sequence? Yes, we can find the sequence. Consider another example. Consider another example. Suppose xn is equal to, not xn, Sn is given. Suppose Sn is given. Sum of n terms. 3n square plus n. How to find the sequence? How to find the sequence? Yes, you can find the sequence. Substituting n is equal to 1. S1 is equal to 3 into 1 square plus 1. That is, 1 square is 1, 3 into 1, 3 plus 1, 4. N is equal to 2. S2, 3 into 2 square plus 2. 2 square is 4, 4 3 is 12, 12 plus 2, 14. Substitute n is equal to 3. 3 into 3 square plus 3. 9 3 is 27 plus 3, 30. Now we get the sequence as 4. This is not sequence, sum. As first, sum of one term means first term. S2 is sum of 2 terms. S3 is sum of 3 terms. So now we can write the sequence. First 4, 14 minus 4, that is 10. 30 minus 14, that is 16. This is our sequence. This is the sum of the sequence. 4, 14, 30, etc. are sum of the sequence. Now consider another example. Consider the sequence 5, 11, 16, dash. Here we know the xn. Xn is equal to how much? Here the common difference is 6. 6n minus 1. This is the xn. Or you can apply dn plus f minus d. That you will get 6n minus 1. Here how to find the sum? Sum is equal, if you add this 5 plus 11 plus 5 is 16 plus 16, 32. 5 plus 11 plus 16 plus like that you have to add. The sequence will be first term 5, sum of 2 terms 16, sum of 3 terms 32, like that. Sum of the sequence. Here you have to find the general form. Sn is equal to 6 into n into n plus 1 by 2 minus 1 into n. What is our general form? A into n plus 1 by 2 plus bn. Cancel. 3 equals 3 n into n plus 1 minus n is equal to, opening the bracket, 3n square plus 3n minus n is equal to 3n square plus 2n. See, 3n square plus 2n is the algebraic form of this, or general form of sum of n terms of this sequence. We can see, we will get this sequence or not. 1, substitute n is equal to 1 square, 1, 3 into 1, 3, 3 plus 2, 5. You get the first term. Now n is equal to 2, 3 and all, we get the sum of the sequence 5, 16, 32, like that. So, consider one more example. Suppose xn is equal to 4n minus 2. How to find Sn? Sn equal how much? Sn is equal to 4 into n plus 1 by 2 minus 2 into n. That is cancelling 2 n into n plus 1 minus 2n. That is, opening the bracket, 2n square plus 2n minus 2n. So 2n square. See, 2n square is the Sn of this sequence with the xn at 4n minus 1. Now we can find the sequence. Here also you can find the sequence. What is the sequence? 4 into 1, 4. 4 minus 2 is 2. 4 into 2, 8. 8 minus 2 is 6. 10. This will be the sequence. Sum of the sequence you give the here. 2 into 1 square, 2. 2 square, 4. 2 into 2, 4. 4 2s, 8. See, 2 plus 6 is 8. Now, 3. 3 square, 9. 9 2s, 18. See, sum of 3. 6 plus 10, 16 plus 2, 18. Like that. If xn is given, you can find Sn, and you can find the sum of the terms of the sequence and the sequence also. Okay. Only this much about the sums in this topic. Everything in this lesson over. Now we have to do the exercise of the sums in the. Okay, let me wind up. I think you all understood the class. In next class we will do the exercise questions of the topic sums.